right, so I'm just looking at page 519, just because this is some other concept, and I mean, it's probably better to explain it a little bit. So arithmetic means these are terms placed between two non-consecutive terms of an arithmetic sequence. So the book actually gives kind of a good example. Let's say there's a sequence 5, 10, 15, 20. It says the numbers 10 and 15 are arithmetic means between 5 and 20. Okay, cool. So like it's just literally, okay, here's 5 and 20. These are the numbers in between. So because 5 and 20 are two non-consecutive terms, consecutive means one coming right after the other. 5 and 20 are not consecutive. They're a few terms apart, but there are these terms in the in-between spot, and these are called the arithmetic means. So class example number 6, it says place 3 arithmetic means between -4 and 8. So let me think, how can I approach this? So pretty much I need to imagine that there's kind of like 5 slots. I have -4, and I have 8. And then I want to be like, okay, well, what are those 3 numbers in between? If this is an arithmetic sequence, what are these numbers? What would these terms be? Okay, well, the book says it is helpful to think of the two, let me show you. It is helpful to think of the two given terms as the first and last terms of a sequence. It is helpful to think of the two given terms as the first and last terms of a sequence. Okay, well, let's just do that then. Let's imagine it that way. Let's imagine that this is T1, because if I'm going to imagine, here, let me just write this down. Imagine that the two terms provided are the first and last terms. Okay, well, technically I'm totally okay with that. So let's say this is like T1. This has to be T2, T3, T4, and T5. And let's just say, okay, well, this is going to be my last term. Okay, cool. So it's a sequence. It has 5 terms. So here's the thing. What do I know? When n equals 1, Tn equals -4. Basically, T1 equals -4. When n equals 5, Tn equals 8, so T5 equals 8. So I know something, okay, that sort of tells me something. I also know this has to be my starting point, right? So I'm just trying to like go back to our formula. and think, what can I plug in here? Well, I could make the unknown that I'm solving for the common difference, because I have enough information here. Like, let's say I focus on this situation. If I kind of combine this information with the fact that my T1, or my starting point, is -4, I could solve for that common difference. Solve for the common difference using the information provided. So, let's set this up. Well, I'm going to talk about T5. T5 has to be T1 plus 5 minus 1 times D. But I actually know what T5 is. And I actually know what T1 is, so I can replace those. I know that T5 is 8, and I know that T1 is -4, plus 5 minus 1D, that's 4D. So now I just have a simple little equation. 8 equals -4 plus 4D. I can add 4 on both sides. 12 equals 4D. Divide both sides by 4, and D equals 3. So, I mean, oh, I don't know why I got super confused for a sec, but no, D equals 3 would work, because if I add 3, that gets me to -1. Then if I add 3 again, that gets me to 2. Then if I add 3 again, that gets me to 5. And if I add 3 again, that gets me to 8. So pretty much when it says place 3 arithmetic means between 4 and 8, -4 and 8, it's just kind of saying, can you sort of determine what these terms would be on the, like, in between -4 and 8, if this were an arithmetic sequence, and there were 3 terms between those numbers. So that's kind of one way of doing it. I mean, you could have also sort of just almost kind of like eyeballed it. If you knew, okay, well, I have to get up 12. I have to get up 12 when I do 4 increases, because this would be the first increase of the common difference. 1, second increase, third increase, fourth increase. So you could kind of like eyeball it, I guess, or think it through in your head, but this is kind of nice to maybe see like a sort of step-by-step path that you could take. Okay, so here's a question from page 520. So here's the thing. It's saying consider this sequence. It doesn't actually have like a ... in the problem. So what I'm gonna do is I'm gonna call this T1, T2, T3, because that feels like that helps me just, okay, it's a chill little sequence. It's just 3 terms. And so they're telling us that this is going to be an arithmetic sequence. So what I know from that is that my common difference must be the same between all consecutive terms. So pretty much like we know there's that formula Tn minus Tn minus 1, which pretty much is just saying if you want to find the common difference, you should take some term from the sequence, any term, and then subtract the term right before it, and you'll find that common difference. So let's try that out. Let's say one common difference, well, like the common difference could be T3 minus T2. So T3 is 2x plus 1 minus T2 is 3x minus 1. So this is polynomial type stuff. 2x plus 1 minus 3x plus 1 negative x plus 2. Looks like my common difference is negative x plus 2. And because I know that my common difference must be the same, I'm just kind of curious, well, what's my common difference when I say T2 minus T1? Because I just kind of want to see, well, it has to be the same, right? So 3x minus 1 minus x plus 2, 3x minus 1 minus x minus 2. Okay, 3x minus 1 minus x minus 2. 2x minus 3. Interesting. Okay. Well, to be honest, I mean, if these both equal the common difference, that's sort of helpful actually, because I can set those two things equal to each other and solve for x. So just double checking that that's all good. So 2x plus 1 minus 3x minus 1, so it's 2x plus 1 minus 3x. Negative 1 plus, yeah, and then minus 1 minus x plus 2. Okay, well, let's just try that out then. So negative x plus 2 must be equal to 2x minus 3. Let's get all of my x's onto the left side. Negative 3x plus 2 equals negative 3. Interesting. Well, if that's my x, I mean, I guess I can try to see, well, what are my values then? Well, if my sequence is x plus 2, 3x minus 1, and 2x plus 1, I can kind of like figure out what those actually equal to. 5 over 3 plus 2, 3 times 5 over 3 minus 1, 2 times 5 over 3 plus 1. So I'm gonna have to make a common denominator. 5 over 3 plus 6 over 3. 15 over 3 minus 3 over 3. And 10 over 3 plus 3 over 3. So 11 over 3, 12 over 3 and 13 over 3. I mean, I guess it is basically an arithmetic sequence. So I can see common difference should be 1/3. So let's double check. Is the common difference 1/3? If I take the fact that d could equal negative x plus 2 and d can equal 2x minus 3 and x equals 5 over 3, just trying to figure out is the common difference actually 1 over 3, negative 5 over 3 plus 2, negative 5 over 3 plus 6 over 3 equals 1 over 3, 1/3. 2, 5 over 3 minus 3, 10 over 3 minus 9 over 3 equals 1/3. So it seems like that actually did work out. Seems like for this sequence, the values actually would be 11/3, 12/3, 13/3. Interesting, interesting, interesting. Taking a look at this example, the third and eighth terms of an arithmetic sequence are 12 and 18. So basically what that's saying is that T3 of this sequence is 12, and then there's got to be some terms in between, and then T8, the eighth term of the sequence, is negative 18. So it says, and this is from the book, page 520, use arithmetic means to determine the fifth term of the sequence. So just flipping back to here, arithmetic means are the terms placed between two non-consecutive terms. So if we have these two terms here and they're not consecutive, the ones in the middle are the arithmetic means. And in the last example, we kind of imagined that these two terms that we're dealing with are the first and last terms. So let's think about that here. So I know that it is actually in the sequence that we're dealing with, we actually have T3, T4, T5, T6, T7, and T8, and just kind of trying to organize myself a little bit. And these numbers in the sequence are 12, and negative 18. But going back to that thing where it's like, in order to determine the arithmetic means between two given terms, it is helpful to think of the two given terms as the first and last terms of a sequence. So let's just kind of keep this on the back burner for a sec. And let's be like, okay, well, imagine that 12 and negative 18 are the first and last terms of a sequence. So for the sake of trying to solve the problem, let's just say, okay, well, T1, the first term is going to be 12, and then T2, T3, T4, T5, T6. T6 could be negative 18. Because if I set this up, and I think that this is actually the first term, and this is actually the last term, then I am kind of in a better spot because just like we did last time, I can use this equation with with D as the unknown. Solve for D, common difference, using this information. Because pretty much what we can do is say, okay, well, if I start substituting some things in, well, T1 in my kind of imaginary sequence that I'm using to solve this problem, T1 is 12. T6 is negative 18, so I can say if n is 6, because Tn, T6, if n is 6, then Tn is negative 18. And then my only unknown is D. So that's how we could set this up. And then pretty much we can solve for D. So negative 18, 12 plus 5D minus 12 minus 12, negative 30 equals 5D. Divide both sides by 5. D equals negative 6. And that most likely is going to work out totally cool. Because, so like, even though we were kind of doing this thing where we were imagining that 12 and negative 18 are the first and last terms of the sequence, it does apply here. So if D is negative 6, then that means this would be 6, because I'm going to be going down 6 every time. This should be 0. This would be negative 6. This would be negative 12. And this would be negative 18. So that works out. So the original question is, determine the fifth term of the sequence. Well, that's got to be 0. So in this original sequence, T5 equals 0. D, we found out, is equal to negative 6. So now, see how like I don't actually know what, I don't know yet. I mean, you can kind of start to think about how you could definitely just figure it out. But T2, T1, I don't actually have the starting value for the main sequence. I know I did this thing where I was pretending that this was my first term, this is my second term, but that was just to find D. Technically, you can see how you could find the first term. You'd be going up 6, 18, 24. Another way you could do that, though, is you could solve for T1 using known information. Because once we figured this out, like before I even know that, and I just know this stuff based on my common difference, you could set up your formula and use really any value of n, why don't we just say, okay, well, when n equals 3, Tn equals 12. So I could plug in all of my known information and solve for T1, which definitely is just going to be 24, but I just wanted to show this because sometimes it could be not as, sometimes you might have more terms and it might be more confusing. So I'm just going to jump down here. 12 equals T1 plus 3 minus 1 times negative 6. 12 equals T1 plus 2 times negative 6. 12 equals T1 minus 12 plus 12 on both sides plus 12 on both sides. T1 equals 24. So for the original sequence, we have this information which we found out by doing some of these calculations. Okay, so last example, and it's actually like basically the same question as this previous example we just did, but I just want to make sure we go through how to solve using a system of equations. So if you remember from chapter 9, the deal with a system of equations is when you have two unknowns, but you also have two equations. And when we have the same number of unknowns and equations, we can basically use algebra to solve for both of these unknowns. So here's the thing. Remembering that the general formula is Tn equals T1 plus n minus 1 times d. So if we are given this information, I can pretty much set up two equations from that, because set up two equations. Because if one of our equations is going to be when n equals 3, because that's T3, so when n equals 3, T3 is 12. So when n is 3, Tn is 12. And similarly, using this information, the term that is negative 18 is the 8th term. So when n equals 8, Tn is negative 18. So here's the reason that this is going to work out is because we have two unknown variables. Our unknowns are T1 and D. But since we have these two equations, we can basically use whatever tools we were using in chapter 9 to solve for both unknowns. So let me get my equations a little bit nicer, just because I know I can simplify a little bit. 12 equals T1 plus 2d. Negative 18 equals t1 plus 7d. And, okay, so if these are my equations, the fact that, like, it kind of looks like I could, oh, wait, I could easily just fully eliminate t1. I was just thinking, oh, maybe I'll multiply and eliminate d, but I can use elimination to eliminate t1. Because if I say, okay, I'm going to take this equation and subtract this equation, 12 minus negative 18 is going to be 30. T1 minus T1 disappears. That becomes eliminated. 2 minus 7 is negative 5d. Then I can solve for d, right? Divide by negative 5, divide by negative 5. d equals negative 6. And I actually know that that's correct because we already solved for that in another question. We just used a different method. And then same thing in chapter 9. Once you have that one value, you can plug this value of d into one of the original equations to solve for t1. So in this case, let's use the top equation. 12 equals t1 plus 2d, but d equals negative 6. 12 equals t1 plus 2, negative 6. 12 equals plus 12 plus 12. T1 equals 24. So yeah, that's actually a really like kind of, it's nice that we can accomplish it that way. It feels a little bit cleaner to think about it as a system of equations. I mean, it's kind of up to you because like we saw, we could solve using the arithmetic means. This just feels very like elegant. So yeah, anyways, that's that.